Thanks for having me, Ben, and thanks everyone for coming. I want to start where I think all good philosophy starts, and that's on Twitter. So here's Jeffrey Hinton, one of the main early proponents of AI, one of the very important developers of AI, engaging in a Twitter debate with Yann LeCun, another very important, influential developer of AI. And he says to LeCun, the central issue on which we disagree is whether LLMs, these are large language models, things like ChatGPT, DeepSeek, like this, whether LLMs actually understand what they're saying. You think they definitely don't, and I think they probably do. Do you agree that this is the core of our disagreement? And as always on Twitter, a bunch of comments ensued. One of the two sorts of impulses in the long thread of comments were expressions of puzzlements. What would it mean for them to understand what they're saying? How would you define that? What part of an LLM's network would understand? What does understanding actually mean for them? How do you even know they understand? Does that mean they have emotions too? So here's all of these people expressing puzzlement about this claim that LLMs understand what they're saying. And there was also intertwined with these some expressions of conviction. LLMs do not understand what they're saying. Believing that they do is beyond absurd. At the end of the day, LLMs are an algorithm. Of course they don't understand and will never understand. They take a bunch of sentences and index it so it forms answers. Here's another one. The LLM doesn't understand anything. It just returns the next token in a loop based on probabilities. You are the one who looks at the results and start making assumptions about what it means. You provide the input and interpret the output. And another strong intuition reflected in a number of comments. I just quote one. Understanding requires experience. LLMs know the word sugar, but they don't know what it tastes like or what its texture feels like. Current LLM models are good at synthesizing words, but they're terrible at knowledge synthesis. They need experience for that. Okay, so this is a Twitter debate. What capacity are we actually ascribing to something when we say of it that it understands what it's saying? Minimally, it seems that understanding what one's saying and using some set of linguistic expressions requires possessing the concepts expressed by those expressions and knowing that you're deploying those concepts in using those expressions. So if an LLM genuinely understands what it's saying when it uses words like red, sugar, guilt, and so on, then it must possess the concepts, red, sugar, guilt, and so on. I don't take this to be a particularly controversial claim. I'm just sort of unpacking the idea of what we're actually saying when we say something understands what it's saying. We're saying it has these concepts and it knows that it's deploying them. So if it lacks these concepts, right, if it doesn't know what it is for something to be red, what sugar is, what guilt is, then it doesn't know what it's saying when it uses the words red, sugar, guilt, and so on. Okay, so our answer to the question of whether LLMs do or in principle could, right, I'm going to leave this sort of modal operator there now, whether they do or in principle could understand what they're saying is going to depend on what our theory of concept possession is. So I want to turn to one approach to concept possession that I've spent a lot of time developing, sort of devoted a lot of my time to developing, and that's this inferentialist approach to concept possession. So here's our question. What is required for concept possession? Answer, mastery of inferential role. What do I mean by that? It's in virtue of mastering the inferential rules governing the use of an expression that one grasps the concept expressed by that expression. I'll spell this out a little bit more determinately, but note first that this sort of underspecifies the view. We can distinguish 4 different species of inferentialist answers. So the weakest way of spelling out this idea is to say mastering the inferential role of expression is necessary for at least some concepts. This is a very weak and uninteresting thesis. A still relatively weak and still relatively uninteresting thesis is that mastering the inferential role of an expression is necessary for all concepts. This is what sometimes it's called weak inferentialism. I'll call it global weak inferentialism, right? So we're applying the inferentialist thesis to all concepts. We think, well, part of grasping their meaning must be grasping the inferential role, but that's only a portion of it. The more interesting types of inferentialism are these strong versions of inferentialism, which claim that mastery of inferential role is sufficient for possession of at least some concepts. So if you think that mastery of inferential role is sufficient for possession of some concepts, you are a restricted but strong inferentialist, or you're a strong inferentialist with respect to that class of concepts. If you think that mastery of inferential role is sufficient for all concepts, then you are what I'll call a global strong inferentialist. And this is the version of inferentialism that I'm interested in. It's the most ambitious and I think most interesting form of inferentialism because it proposes to actually give an account of concept possession in general. It says what concept possession is mastery of inferential role. So we would have an account of concept possession if we can get this global strong inferentialist view to work. And this is the view that I've spent a lot of my time developing, and I think has a lot to say for it. Now, here I want to consider an argument with respect to global strong inferentialism, having to do with the relationship between this view of concept possession and the question of whether large language models genuinely possess concepts such that they can be counted as understanding what they're saying. So global strong inferentialism, just once again, this is the view that mastery of inferential role is sufficient for possession of all concepts. Here's a plausible claim. Training on linguistic data, so being given a massive set of linguistic data and somehow through some set of algorithms training on that is in principle sufficient for mastery of inferential role. If you get a big enough set of linguistic data and you have an efficient enough set of algorithms, it's in principle possible through training on that linguistic data with the use of those algorithms to master the inferential roles of all of the expressions used in that massive set of data. I can say more about that, but I just want to say, look, this is prima facie plausible. Okay, so a consequence of this is that training on linguistic data is in principle sufficient for possession of all concepts. This just follows from these two claims. So a consequence of this is that large language models trained on nothing but linguistic data are in principle capable of possessing all concepts. So my aim in this talk is somewhere between the following two extremes. Minimally, I want to convince you that the validity of this argument is not a reductio of this position about concept possession that I really like. That is to say, you shouldn't, if you think the conclusion is so absurd, you shouldn't just reject global strong inferentialism. So minimally, I want to say, well, this isn't just a reductio ad absurdum of this view of concept possession. Maximally, I want to convince you that this argument is actually sound. I hope what I do will lie somewhere between the two. Okay, so in order to, so once again, my interest is global strong inferentialism, but to get a feel for this view, it's helpful to start with restricted strong inferentialism. And the most common version of this, the most widely accepted version of restricted strong inferentialism is what's called logical inferentialism. And that's the view that the meanings of logical connectives like not, and, or, and so on can be understood entirely in terms of the inferential rules governing their use. And the reason this sort of view has attracted so many adherents, the reason why it's regarded as so plausible, is that standard sort of proof systems that you get in logic seem to give you a way of specifying these rules, right? So for instance, if you've taken an introduction to logic class, you might have learned a natural deduction system where you have rules like the following. So this says from A along with B as premises, you can infer the conclusion A and B, right? So this is an introduction rule. It tells you how to conclude A and B from A and B, right? This says here are the conditions for inferring A and B. If you've got A and you got B, you can infer A and B. And then corresponding to this, in a natural deduction system, you have a set of elimination rules, which says, well, if from A and B, well, then you can infer A. And if you have A and B, you can also infer B. There's other ways of formulating proof systems. I often like to work in terms of what's called a sequent calculus. The details really aren't too important, but this sort of says the same thing just in a different way. This says if from A along with B you can conclude something C, well then from A and B you can conclude C. So this here would be just a set of whatever else your premises are. If from that set of premises along with A and along with B you can conclude some conclusion, then from that same set of premises in A and B you can conclude that conclusion. Really what this says is that A along with B plays the same role as a premise as A and B. And this says if from some set of premises you can conclude A, and from some set of premises you can conclude B, well, from that set of premises you can conclude A and B. It's not too important to get hung up on the details of how this sort of proof system works, but I'm going to use sort of rules of this form and sort of spelling out some inferential rules. So this is just another way of formally specifying the inferential rules. And the idea of logical expressivism is the thought that, look, specifying the rules governing the use of and in a proof system of this sort suffices to give you the concept expressed by and. This is an account of the concept expressed by and in terms of the inferential rules governing its use. Okay, so that's logical inferentialism, which is a version of restricted strong inferentialism. What about global strong inferentialism? So the idea here is that it's not just logical words, like and, but also content words, like red, sugar, guilt, and so on, that can be understood in terms of the inferential rules governing their use. Can I shut this? I'm like burning. I think I shut it off. No, that's okay. Whatever. I don't think I did.
You succeeded.
Yeah, no, I'm just thinking so. Okay. Okay, so global strong inferentialism is the view of not just logical words like and, but also content words like red, sugar, guilt, whatever your favorite words are, can be understood in terms of the inferential rules governing their use. Okay, so just take, for example, the meaning of red. The thought is, well, it can be understood in terms of the fact that its use is governed by inferential rules such as the following. From something is red, right? A is just an arbitrary thing, right? So if you say something's red, well, then you can infer that it's colored. You might say, well, if you say that it's red, then you're committed to saying that it's colored. There's different ways of spelling out exactly how to think about the inferential relations here, but the idea is from red, you can infer colored. Similarly, from scarlet, you can infer red, right? And so this sort of corresponds to like an elimination rule. You're inferring something from red, and here is, you're inferring red from something else, right? So you give the rules specifying the conditions from which you can, the conditions to which you can infer red, and the consequences from which you can, if you know that something's red, you can infer something else. There's also rules like this, right? This just says, well, this is incoherent, right? So this says, if you say something's red and you also say it's green, all over, just treat that as implicit, then you've said an incoherent set of things. You have an incoherence. And also, it's not just the one place things, right? If you say something's red and you say something else is pink, then you're committed to saying that the first thing is darker than the second thing. So these are the sort of inferential rules governing the use of red. But it seems like there's a problem with this sort of theory, right? It seems like, look, I've only specified the meaning of red in relation to other colors, and it seems like maybe inferential rules of this sort are necessary aspects of the meaning of red, but they can't possibly exhaust its meaning. And one important aspect of the meaning of red is that it can be properly deployed non-inferentially upon seeing that something's red, right? So if I see a red thing, then I can use the expression red. And that seems like an essential aspect of the meaning of red, right? It's the sort of thing that can be deployed on the basis of perceptual experience. And that, it seems, isn't the sort of thing that can be captured in inferential rules of this sort. So this seems like a problem for global inferentialism. Now, the standard response to this problem is to distinguish between two sorts of inferential rules. So first, there's the properly inferential rules, right? The ones that actually obtain between sentences or uses of language, like assertions, and other uses of language. Those are the sorts of things that I just showed you. But also, there's what we might call quasi-inferential rules. These obtain between uses of language and non-linguistic perceptual circumstances or intentional actions. So here's the thought. We have something like this. So look, if I see a red ball, I can infer the ball is red, right? This over here is just a representation. This just here is just a representation of seeing a red ball, right? But the thought is, look, from this actual concrete perceptual circumstance, then you can infer the sentence, right? And this over here isn't a linguistic thing. It's an actual sort of perceptual circumstance. And the thought is, okay, well, if we have all of these inferential rules, we need to supplement them with these quasi-inferential rules to take care of the fact that red is essentially such that it can be deployed perceptually. I think this is a bad view. I think admitting such quasi-inferential rules into an inferentialist semantic theory essentially amounts to abandoning strong inferentialism, right? Because this really isn't an inferential rule at all. And if you say, well, you know, among the rules that are accounting for the concept of red are things like this, well, now you're stuck with these things in your semantic theory, and it seems hard to understand how you can make sense of this without actually just deploying the concept red, right? And so I argue in this paper of mine that called How to Be a Hyper-Inferentialist, that these views with these sort of quasi-inferential rules are, insofar as they really supposed to account for concept possession, they end up being circular because you can only make sense of them in a way that involves presupposing the concepts that they're supposed to account for. I'm not going to go into this argument here. I hope you can get a sort of intuitive sense of why something like it might be plausible, but I don't like this strategy. Okay, so then what do we do? Stay strong. Don't give up strong inferentialism for weak inferentialism. Be a strong inferentialist. Only that will give us the promise of actually accounting for conceptual contents. But how do we do it? More inferences. All the inferences. I don't know, these are memes from like when I was in college. Some people might get them, it's okay. So when I was sort of giving this sort of intuitive sketch of the inferential relations that figure in an inferentialist theory of meaning, I just talked about what we might call intrafamilial inferences, right? So these are inferences between colors and other color words, right? So these are intrafamilial, right? They're all within the color family of words. But clearly, that's not enough. We also need extrafamilial inferences. So one sort of these are sort of normal, what we might call material inferences, right? So we have to connect red to the red things in the world in terms of the inferential relations. So for instance, from the claim that something's a stop sign, you can infer that it's red. From the claim that something's a blackberry and it's ripe, you can infer that it isn't red, or you can infer that it's incoherent to say that it is red. But once again, these don't account for the fact that red is essentially such that we can deploy it upon seeing something red. How do we account for that aspect in inferential terms? Well, like this. So if something's red and someone has color vision and that person is looking at the red thing, then they see that it's red. Yeah, it's simple. It's just an inference. And this accounts for the fact that it's an essential feature of the content read that it can be deployed perceptually. We account for the fact that it can be non-perceptually deployed in inferential terms, right? This gets incorporated into the inferentialist theory of content. So the strong inferentialist claim is that such inferences, properly so called, right? The only things these are relating are sentences, suffice to completely articulate the content of read. No quasi-inferences are needed. For more details and fewer memes, you can look at my paper, How to Be a Hyper-Inferentialist. There I actually spell out what these inferential relations look like in some detail. This is sort of a toy example just meant to give you the basic idea of the proposal. But if you want to see in a little more detail what these inferences actually look like, you can look at the paper. But this is the view that I've defended elsewhere, just in terms of how to spell out the inferentialist picture, such that you don't need to appeal to these quasi-inferences. Okay, so I want to look at some consequences for this view, eventually turning to the case of LLMs, but let me first turn to a case that might be familiar from the philosophy of mind. Frank Jackson famously proposed this thought experiment called Mary's Room. Maybe some of you have heard of it before. The idea is that Mary is a color scientist who's been locked in a black and white room since birth. Really, that doesn't really work, but make her colorblind or something. Ignore that feature, right? She's locked in a black and white room since birth. And she's never experienced color, right? But she has access to all of the books and all of the knowledge that's been developed on color. She spent her life dedicating color, she's dedicated her life researching color, and she's reached the theoretical limit about what can be known about colors without actually having experienced them. So here's a question. Does she know what it is for something to be red? The standard intuition is no. Of course she doesn't know what it is for something to be red. To know what it is for something to be red, to have the concept red, you have to experience some red things. You have to see red things. You have to have red experiences. However you want to articulate it, it seems like Mary doesn't have the experiences required to know what it is for something to be red. I think that view is just wrong. I think she knows exactly what it is for something to be red. She grasps all of the inferential relations between sentences that articulate the concept red. So she grasps the conceptual content expressed by red. So she never herself has used the term non-inferentially, right? Ex hypothesis, right? That's just how the thought experiment goes. But she knows just the conditions under which it can be non-inferentially used. And that's all that's required to be counted as knowing the meaning of red. Now, this claim is obviously quite unintuitive, but I don't know what the non-question begging argument against it is. Look, she grasps the content of red because she knows all of the inferential relations that constitute this concept. If you ask her what it is for something to be red, she can tell you. What is she lacking? She hasn't seen red, but of course she hasn't seen red, right? We've stipulated that. Any sort of further insistence, it seems to me, is just going to amount to table pounding. And actually, we can turn the crank one step further. By the very same reasoning, we can argue that not only does Mary know what it is for something to be red, but she knows what it is to see that something is red, right? Once again, she hasn't herself seen anything red. She hasn't herself experienced redness. But because seeing something red is inferentially articulated in just the way that red is, she knows what it is to see that something is red. So, I grant that this is running against many of your intuitions, and I'm happy to discuss that. But this is my view. And the question I want to ask is whether this same basic thought might be applied globally, right? So in this particular case, we have Mary who lacks a particular experience, namely seeing red, and we can argue that, in fact, she is capable of possessing the concept of redness, right? So this is a local case, right? But could this same basic strategy be applied globally to something without any experiences at all? So to do that, I want to make a distinction between what I'll call sentience and sapience. This is sort of drawing on Robert Brandam's work. Sentience is conscious awareness. Sapience is conceptual understanding. Okay, so given these two categories, I'm not going to sort of define them right now, but we can start sort of sorting things just intuitively into these different boxes, right? So some things have neither conscious awareness nor conceptual understanding. Rocks, trees, thermometers, right? None of these things, at least intuitively, have either conscious awareness or conceptual understanding. Some philosophers have argued that trees are conscious, but ignore them. Intuitively, right, we can start sorting things into these different boxes. Now, some things are sentient, but not sapient, right? So they have conscious awareness, but they lack conceptual understanding. So lions, ferrets, octopi, you name it. You sort of get an intuitive sense of what goes in these boxes. Other things are both sentient and sapient. So us, right? We have conscious experiences. We know what things taste like, and we feel things, and we have pain and things like that. And we also conceptualize those things, right? Not only do I feel pain, but I can think the explicit thought, pain is harmful, right? Or, there ought to be less pain in the world, right? These are the sorts of things that come with conscious awareness, with conceptual understanding. And so, though a lion might be able to feel pain, right, it's not able to think such thoughts as there ought to be less pain in the world. Happy to discuss this too, but we're capable of thinking determinate thoughts about things. And that, I take it, is what distinguishes us from other non-linguistic animals as distinctively conceptually understanding creatures. So we're in this box. Also, Klingons, other sort of linguistic aliens from science fiction, right? When you have, the Klingons on their starship engaging with the humans, where, just intuitively the way the situation is described, we're led to believe, maybe they have really different experiences than us, right? They use different sensory capacities or whatnot, but like us, they're both consciously aware, and they have this sort of conceptual understanding that we have. And also sort of familiar depictions of what we might think of as strong AI, right? Really understanding AI, right? So there's this movie by Steven Spielberg, AI, where one of the artificial intelligences is a child, not a human child, but an AI child who has, where at least the way this thing is depicted, led to feel that he has the sorts of experiences, maybe slightly different, but something analogous to the sorts of experiences that we have. He feels guilty, he feels sad, longing, pain, and also conceptual understanding. So basically all of the familiar cases we have of sorting things into these different categories fall into one of these three boxes. Until very recently, I thought that nothing could possibly go into this box. But now I want to convince you, or at least suggest to you, that maybe LLMs could in principle fall within this box. That is to say, LLMs could in principle be understood as possessing genuine conceptual understanding without having conscious awareness. Okay. So, spelling this out requires me saying some things about what each of these things are. I can't give you a full picture of consciousness here. That would take way too long. But I do just want to sketch the contours of the sort of view that I like, just to make my claims a little more concrete. So I'm going to sketch what I'll call a broadly Heideggerian picture of consciousness, drawing from Martin Heidegger and some analytic philosophers sort of following Heidegger. So what is it to possess conscious awareness? Here's an answer. It's to have a world in which things show up to one as significant in various ways, as to be responded to in various ways, given one's ends. So just for example, right, I said the lion is conscious. What does this sort of most fundamentally involve? On this sort of view, it's the fact that the lion has what you might call a world of significances, right? Things in the world show up to it as practically significant, right? So the gazelle shows up as to be eaten, the cub shows up as to be nurtured, and so on. This is a sort of, you might call it a Gibsonian view. Gibson also endorses this kind of view. And on this kind of view, you might think of conscious perception as sort of one aspect of the perception-action nexus, right? So the basic picture is, right, you have something which has some aims, some ends, right? It's going about the world, achieving those ends, and things show up to it perceptually, and that's the sort of receptive aspect of this perception-action nexus through which it intelligibly interacts with the world, going about achieving its ends. And just the way I've described it, this involves what John Hoagland calls giving a damn, right? It requires being something that in some ways cares about its ends. It requires having aims and working to achieve those aims and things showing up as to be done in the context of those aims. Okay. So that's sentience, right? This is just a sketch, but this is just a broad picture of the sort of view of sentience that I find attractive. What about sapience? Well, here's Robert Brandom on conceptual understanding. He says, our transactions with other things and with each other, in a special and characteristic sense, mean something to us. They have a conceptual content. We understand them in one way rather than another. What is it to possess this sort of conceptual understanding? Well, that's what I've just been telling you. It's mastery of inferential role, right? What it is for things to have this distinctive sort of conceptual content that we grasp is for us to master the inferential roles of linguistic expressions with which we can talk about those things. And once again, the global strong inferentialist view is that mastery of inferential role is in principle sufficient for possession of all concepts. Now, for us, I take it that conceptual understanding transforms what it is for us to be consciously aware, right? So if you look at Brandom's description, right, our transactions with the world, right, our intelligently engaging with the world has conceptual significance for us, right? These things in the world show up to us not as just sort of practically significant, but conceptually significant, right? We know what these things are and we grasp their meaning. So our form of sentience is a distinctively sapient sentience. But could there be a form of sapience without sentience, right? That's the question. So let me now turn back to large language models, just say a little bit about how these things work. So the case on which I'm going to focus here is what I'm going to call pure LLMs. These are things trained on nothing but linguistic data. So basically all of the text that's ever been produced. Current models, there's a lot of what are called multimodal models that are trained on more linguistic data. I think these arguments carry over there, but I just want to focus on the case of pure LLMs, which are just trained on linguistic data. And here's basically how it works. So these are neural networks. They're trained on massive amounts of linguistic data. So basically they have these crawlers that crawl the entire internet to produce all of the text that's ever been printed on the internet. And then they get these algorithms that are trained to predict the next word, right? So, if you have a massive amount of text, you can see if you've predicted the next word correctly or not, right? And so there's a reward function, and they're trained for a long time so that they get better and better at predicting what the next word will be. Then they're trained on sort of specialized data so that when you actually engage with these things, they actually answer your question. If you don't do this, then if you ask them a question, they'll think they're just like in a text of long questions, and they'll just say more questions. So trained on these specialized data. And then the way it works is you ask a question, and it responds by just predicting the next word that's going to follow your question, right, the start of an answer. And then once it does that, it feeds that back into its context, predicts the next word that's going to follow that, and then it says that thing, and it reiterates this process. Current reasoning models, there's some complications. They sort of do this thing internally before actually spitting out an answer. And there's also another stage of reinforcement learning on those internal dialogues. Nothing really changes based on that, but I'm happy to talk about that in the Q&A if you have questions about where the technology is now. But the point of all of this is that LLMs don't give a damn. They're not the sort of thing that care. They don't have the sort of ends that living creatures do. And in this way, there isn't a world that's going to show up to them as significant, as to be responded to in various ways. Now, John Hoagland, who's a famous critic of certain sorts of artificial intelligence, claims the trouble with artificial intelligence is that computers don't give a damn. And what I want to say is that he's certainly right that they don't give a damn, but he's wrong that this causes any trouble. This, in fact, is no problem at all. So to turn to a specific case, I want to look at the capacity to read. So current LLMs are, as we all know, limited in various ways. But one thing they can do, I take it, is read. That is to say, they can take a text, summarize it, and understand its meaning. Can GPT-4 or any of the current models that are out right now produce profound literary analysis? No, of course not. They can't. Don't try to do this for your literature paper. You'll get a bad grade. They can't quite do it. But they can score better than 93% of high school students on the reading portion of the SAT. The SAT is like the American version of the Gaokao. Substitute that in. But they can do it, right? And these are novel texts that they can be given and score a higher score than most high school students. Will GPT-6, say 2 iterations down the road, be able to do serious literary analysis, even if, let's stipulate, it's just a pure language model? I want to say maybe. I don't think we have any reason to think that it won't be able to do such a thing. Now, John Hoagland argues that computers can't read. Here's what he says. He says, only a being that cares about who it is as some sort of enduring whole can care about guilt, or folly, or self-respect, or achievement, life or death. And only such a being can read. By that he means only such a being can really understand the content that it is processing. I think Hoagland is just making an error on this view. So understanding the meaning of a fable or a Dostoevsky novel doesn't require giving a damn oneself. It just requires knowing what it is to give a damn. So just as I've argued Mary can understand what it is to see red without herself seeing red, an LLM can know what it is to give a damn without itself giving a damn. An LLM can know what it is to feel guilt and thus understand the terrible peril of the character in this novel without itself ever feeling anything remotely like guilt. To think that you have to feel guilt in order to understand what guilt is on this view is just a mistake. All you have to do is master the inferential relations, articulating the content of that concept. Okay. And I've said all of these things, but you might be left wondering, come on, these LLMs, they're just spitting on answers they don't really understand, right? There's something that they really don't understand, right? But once again, I think we should just question what we're actually asking here. So here's a famous quote from Wilfrid Sellars, one of my favorite philosophers, probably my favorite philosopher. He says, in characterizing an episode or state as that of knowing, we are not giving an empirical description of that episode or state. We're placing it in the logical space of reasons, of justifying and being able to justify what one says. So here's a spin on this basic Sellarsian thought. So what am I saying when I say, well, these things really understand? Well, in characterizing a system, whether it's a human being, an extraterrestrial, or a computer program, as reasoning or understanding, we're not giving an empirical description of that individual. We're placing them in the logical space of reasons, of justifying, and being able to justify what one says. So the question we should really be asking, the question that's underlying this question of do they really understand is, can we rely on them? Can we trust them to respond appropriately to further queries and challenges, clarifying and explaining what they do and what they say in an intelligible way? And if you work with current LLMs, you'll see that sometimes they can't. Sometimes this fails. But I take it that LLMs, the answer is in principle, yes, right? There's no in principle reason to think that they couldn't completely satisfy the conditions for being attributed genuine understanding. Okay. So I've been talking sort of very theoretically, abstractly about this question of whether we should attribute genuine understanding to these large language models, and I've suggested the answer is in principle, yes. Now, let me sort of bring it down a little bit. Why do we actually care about this question? So here I take it is what we want in at least certain types of AI systems. Now, some AI systems like butlers and whatnot are another thing, but at least in large language models, what we want is systems that truly understand what we're saying to them and what they're saying back to us. How nice it would be to have such a system as a research assistant. What we don't want is AI systems that kill us all. So the first thing, what we want is sapience. However, with sentience, with giving a damn, the risk of the second thing goes exponentially up. Now, I think there's a widespread assumption in the contemporary discussions of AI that the path to genuine artificial superintelligence looks something like this, right? We start out with ant intelligence, then we get bird intelligence, then we get monkey intelligence, then get human intelligence, and then finally, eventually, past human intelligence, we have superintelligence, right? Which is like the same sort of thing. It's just higher up on this scale. And you can see this commitment reflected in some of the most important figures in AI today. So for instance, Jan LeCun, sort of against certain AI safety regulation, calls for AI safety regulation, says, it seems to me that before, quote, urgently figuring out how to control AI systems much smarter than us, we need to have the beginning of a hint of a design for a system much smarter than a house cat. And I take it that LeCun is assuming something like this model of intelligence. Now, he thinks he has good reason to think this is right, but he's assuming, right, that this is going to be a linear sort of thing, right? We're going to achieve house cat intelligence, right, which I would classify as a kind of sentient intelligence, right? A house cat is very good at intelligently navigating its environment, and we don't have systems that do that. And he's assuming that because of that, we're not going to have systems that genuinely understand the concepts that they're deploying when they use language. And I think that's just a mistake. So if sapience without sentience is possible, as I've argued that it is, this is at least not necessarily the only path that superintelligence could take. Now, perhaps, practically speaking, the easiest way to true sapience is through sentience. I don't know the answer to this question. I'm not an AI researcher, but also AI researchers don't currently know either. There's debates on whether LLMs, which everyone agrees aren't sentient, are the path to true sapience, or whether we need some radically different architecture, as, for instance, Jan LeCun argues. So I don't know the answer to this question. But as we do the sort of risk-reward calculations, as we develop more and more capable systems, an important consideration is whether there is at least a theoretical possibility of sapience without sentience. And I hope I've done enough to convince you here that at least the very idea of such a possibility is not completely crazy. Thanks.
Quick 2-minute break and then questions.
First minute.
Yeah.